programming engineers. Welcome back once more to this drives course. And in today's topic, we're going to view our start and stop now for our PowerFlex drive from Allen Bradley. So the drive that we're going to configure is our 525 model. So there are different categories for drives in the Allen Bradley brand. And its main its main characteristic for the 525, which is the model, is that it has Ethernet embedded. So what I mean by this is that the communication is ready to be used by Ethernet. So it's already setting us up to have communication between our drive and our PLC. Our PowerFlex 523, for example, is our drive that does not have embedded communication. It has no Ethernet port. But it doesn't mean that it cannot communicate through Ethernet. But what we do need is to acquire a communication card that is independent. My recommendation is that if you already know that you're going to use Ethernet communication, get the 525 drive. And this is for pretty small motor potencies. For 2 HPs, 3 HPs, that's what the 523 is for. Now, we also have our other PowerFlex category, which is more robust. When I say robust, I'm talking about the capacity that we have with our drives of controlling bigger and better potency in a motor. So we have the 573 and the 725s. The difference here is that the 753 does not have embedded port, but the 755 has the Ethernet embedded port. Okay, that's the main difference. Now, here we're going to view two manuals. One of them is in Spanish and the other one is in English. So I'm leaving it to you in the resources part, whichever you wish. My recommendation is in English so that you can get familiarized with this. Now, remember that this course is focused mainly on the guarantee that you guys are going to be able to configure basically any drive for any brand. Now this through our inputs and our digital outputs so that you guys know how to configure them. Its most general setup, which around 95 or 90% of the industry, they can handle. So the motors start and stop. Okay, tuning, etc. However, by the end of this course, the bonus part, the cherry on top, is that I'm able to show you our configuration from zero, from scratch, so you can set up communication between our PLC and our PowerFlex, and also that we can run programming. Okay, so this section is to finish our configuration for all 4 brands that we've seen throughout this course. But later, remember guys, I'm going to assign you different information for parameters and for the acceleration and deceleration, as well as auto tuning, its differences, etc. And then in the end, we're going to go back to our PowerFlex 525 so that I can show you guys your communication configuration. Now, we're going to finish this section through our Excel spreadsheet. So I already hit on this side the other drives. that we already had our identified parameters, just so that we can focus on our PowerFlex 525. So now let's start this off. I'm going to head out to my manual, and I'm going to look for the data plate information. Remember, you guys can pause the video, you can run the exercise, and you can compare if these parameters are right or not. Okay? Now get data plate information. It's these ones. So let's see which categories they're on. So this is installation, and we're going to look into this in the future. This is startup. Okay? This is the most common startup, actually. But I'd like to see the parameter part. And probably they're going to be on this part for the basic display group for 76. And here we go. We have B01. Here we have our frequency for our output. But let's add this anyways. So this is only for us to have a reference. So the commanded frequency, I'm only going to check 2 of them. So output current for the motor. Now, something you should keep in mind with these drives is that you need to be very careful when checking the voltage for your PowerFlex 525 or the 523. Because generally, the Allen Bradley brand asks for these types of drives, and they have more stock with 380 volts, logically AC, and up. So they went a little bit more towards the industrial part. I'm not saying that 220 is not industrial, but they're focusing a little bit more on the bigger plants. Okay? So most of their models are 380 volts. So you need to be very careful with this. Now, basically, that's why you're probably listening to my voice sounds a little echoey. Because what I'm right now, the office where I'm at, I had 220 volts, and everything that I've been practicing on lately, we've practically been doing them in our office. But there hasn't been any requirement on behalf of the drives to ask for more voltage, except for the PowerFlex 525, which is the one that I have right now. So therefore, I had to exit the office, and I had to run to my other offices where we run all of my automation work, my machine. I have a different business I don't know if I told you about previously in this video, but for those of you who know me, know that what we do is we work in machine manufacturing, and it's an industrial ship where we have a lot of echo. Okay, so again, I apologize, but I was testing this out, and there's very good sound, but there's a slight bit of echo. So outside the office, on our testing part, I have my connection of 440 or 480. So it works perfectly. Our PowerFlex works perfectly. All right then. Now, output voltage. Do you guys remember? I'm not going to change the motor because it uses 220 volts AC. But here, it is absolutely necessary to change our output voltage because it's set up at 440 or 480 volts. I'm not sure. That's why I want to check this. That way, we won't have any sort of issues or problems at the moment when we connect them. Okay, so I wouldn't want to burn that motor out. And so, therefore, it's part of what we do in these videos. to run configurations, set them up from 0, and you guys could get an idea on what we could get at the moment when presenting or when setting up. Okay, so drive steps. All of this is for our motor part. We have here our control reference or our startup reference. Okay, so this is B02 parameter. Sorry, B012. Now, what else do we have here? We have, well, I'm actually going to explain this in the near future, which is our control words and our status word. Okay. Here we have our velocity for our motor, which is B015. In RPMs, and here we have it in frequency. So here we have our motor potency, which we need to enter logically. Our saved energy. Now, I love these drives because they have a ton of parameters and we can optimize them in a way for our application. So these types of apps are for pretty robust systems where we can use all the potency or all the available potency for our parameter existence. So we have many parameters for these types of drives. So many so that honestly, we need to be very analytical when checking what we need for our application. Now, logically, we're going to make this process more efficient. And then we have select connection types and digital inputs. We're going to look for 2-wire. And here, we show this. And here, these are our parameters. But I think I'm also going to go back a little bit, which actually here it is, we have everything on our control part for our status, our potency. And here I would have thought that we have your language, or the language part. Here we have our motor part. But here we have our overcurrent. So this is also essential. This is actually for permanent magnets on the torque part. Auto tuning, which we're going to look into it later. So we're going to be working with acceleration and deceleration. Max frequency, and we're going to leave it as such. No, I don't see it here. I thought it was going to show up, or I thought it was going to appear on the basic parameters. Oh, here they are. Okay. So we have now our configuration, our predefined configuration, our preset. So I need to view how the connection is. There needs to be something a little bit more simpler. Actually, this is already done. So it's 3-wire. So let's see here. There it is, 2-wire. As I think I remember for these types of drives, but it's just it doesn't show up as simple, but I think we have different ways of connecting our 2-wire and our 3-wire. I think I remember that there's a way in case we don't want to use our internal font, our internal source, where it has a start-stop sequence circuit, and we can select the external part. So it has different configurations aside from seek and source. That's what I'm looking for. But it should not be complicated. Let's see, let's look for it here. So 3-wire. Exactly the same thing. Okay, let's look for this parameter, just so that we know if we can do this or simply any one of these. So here we have another option, which is basically the same thing. Okay. Or we're probably going to look for it here. In Spanish, it's this one, this part here. This is what I was saying, but this is in Spanish. It's weird that it's not in English, but let's see if we have installation and wiring. More than configuration is wiring. So here, for example, we have here for page number 44. Let's see if this matches, because sometimes it's being adjusted. So here we have some examples. And we actually have some examples for our potency meter. And this is what we were looking for. So in this case, it was useful to have the Spanish manual. Now, what do we have here? We have our analog part, our velocity part, as we see for our potency meter, which is pretty simple, where we have our recommended characteristics, but here our pulse train. What we need is actually our 2-wire connection, and our 3-wire as well. This is what I was saying. For example, we have an option saying if it's source, then connect them to these terminals. But if you want an external source, then connect it this way. Then you should have your own voltage. And then we have, if we were to want a sync control, but no reverse, then this is what we could be saving on. And then we have, if we want a source control, but with reverse. So these are no reverse, and this is reversed. External and internal. And then we have our no control internal without reverse, no reverse. And then we have the one that we are interested in, which is the 3-wire type. No reverse with our source control. And then we have our sync form, but with reverse. So since we already have our switch, we're going to use this. And most assuredly, it should be in source configuration. So therefore, we're going to follow this part. Okay, now, what are our parameters? P046. So P046. And what else is this asking us for? It's asking us that our blocks need to be configured the following way, which is block 3062, digital input, should be the same as 49, which is where we're getting our configuration for our input, our digital input, which actually, as to not get confused, let's copy them as such. Okay, here we go. Now, let's paste this on the bottom part. So for inputs and outputs for our drives. Now, here we go. and I'm going to eliminate this part. Okay? So now we basically have our parameters. Now, the only thing that's missing is our motor velocity reference. And I think I uploaded it on this part a little while ago while we were there. Let's see if it shows up here. So control source. And here we have our frequency command. Doesn't say anything. This is our startup motor. So right now, we are in our P047. So we're going to add him. Now, to my liking, these are the parameters that we need to start up our motor, externally at least, with our digital inputs, with our buttons, and with our motor setup. So compare them with your results and analyze if we are right, or if not, which parameter would you check? So we're running this, all of us, in a more real and effective way through a possible situation, a possible real situation where we would actually be interested in case you find some additional information that I'm telling you about. So here, for example, for our drive that I was telling you about, which is generally 380 volts to 480 volts, where we need to change our output voltage for our motor so that we won't burn this out. Now, with this, we are done with our video, and we're going to go to our next video to run our PowerFlex setup. And we'll see how this is controlled. Big hug, guys, and I'll see you on our next video.